Good morning, everybody. My name is Chad Ullman. I am the wide format manager here at Tierney Brothers, and 3D printing is kind of an offshoot of what we do. So I want to thank everybody for coming today. For everybody who got some coffee and some rolls and stuff. We've got a very special speaker today, Sarah, who is our manufacturer's rep and 3D printing expert. So she's going to go through a bunch of stuff with you with 3D printing, and then we'll kind of break out and we can do some more one-on-one question and answers later on. So I will turn it over to Sarah, but I wanted to thank everybody for coming out today.
Hi everyone.
Good morning.
So we're going to go through a variety of things around 3D printing and scanning. I like to be pretty interactive, so feel free to raise your hand and ask some questions so that we can kind of address the things that you're thinking about. And we'll just dive right in. So one of the first questions I get asked is who is going to buy a 3D printer? Who is going to use these things? People like architects are already working in CAD design software. They're already making models. So 3D printing is a natural extension of the work that they're already doing. It's just a new and inventive way for them to make models of their work. People in the engineering and manufacturing fields or anyone teaching that as a subject matter is also a natural fit. You're designing a new product or wanting to test out some prototypes. 3D printing, which is also referred to as additive manufacturing, is a great way to do that and offers a lot of advantages over more traditional subtractive manufacturing methods. Inventors, people in fields like robotics, for example, love 3D printing because it gives them that immediate feedback for the designs that they're testing out. And somebody who's wanting to get a business off the ground or is straight out of school and wanting to try out a new idea can make a minimal investment in a 3D printer and do some small short-run manufacturing before they have to invest in a large-scale manufacturing run for a product. So it allows them to kind of get their foot in the door and try out new ideas a little easier and more cost-effectively. Artists, designers, anyone in the creative field has amazing new tools and materials with which to work. And people in the hobby, gaming, technology enthusiast type category love 3D printing, obviously. All these kids that are coming up through the schools now sort of have this expectation of being able to have a custom version of something just for them. A personalized version of an iPhone case or the little model of their favorite gaming character or what have you. And that demand for personalization and customization really fits well with something like 3D printing and 3D scanning. Last but not least, of course, is education. I think 3D printing and 3D scanning as an educational tool is a huge amount of opportunity and promise. We'll go through many examples here in a moment, but I've spoken to a lot of schools that have had great success with 3D printers in their classroom and 3D scanners as well. So that's what we're here to talk about today. So the next question I usually get asked is, what the heck am I going to do with a 3D printer? So talking to schools specifically, what I usually like to do is go through the different topics and classes and how 3D printing might apply to that. So in a biology class or pre-med, you can take imaging that's already being done with CT scans, things like that, and then output a very exact model with a 3D printer. Surgeons are using 3D printing to print out those models to not only practice complex procedures before they have a patient open on the operating table, but they're also using it as a way to explain to patients what's wrong and how it's going to be fixed. And that's actually a big problem in the healthcare industry, this lack of communication between doctor and patient. And being able to see a model of your actual bone that they're mending or heart that they're going to be operating on is a really effective tool. People in chemistry or anyone studying some sort of nanotechnology can print out these tiny, tiny things that they're trying to study, models of them on a larger scale. And you can have kits, little DNA strand kits where the students actually piece them together to understand better how they work. But anything that's teeny tiny, scale it up to an actual model and print it on a 3D printer. Again, people in engineering courses or automotive type class can print out modified car parts, design futuristic vehicles. They can replicate parts for older vehicles that aren't in production anymore to do repairs, things like that. They can test out their designs in wind tunnels, things like that. There's a local program. I'm from South Carolina, and they're doing some futuristic vehicle designs, things like that. I'll have Bob talk about that a little bit in a minute. Geography students, anybody studying mapping or people in the oil and gas and mining industry want to add that third dimension, the topography, to the maps and the plans that they're studying. And especially when you have something like a color 3D printer, which we have some examples of a full color 3D printer here today, it really makes it a much more dynamic and detailed depiction of the areas that they're studying. For example, you can, I've seen a model, I have a model, not here today, unfortunately, of a factory, and they were analyzing what would happen with the waste material from that factory as it spilled out into the ocean. So they were able to do a topographical model of the factory and the ocean in different pieces and parts, and then they did a heat map that would show, you know, the red was most concentrated of the waste material and how it dispersed out into the ocean. A really effective way to look at geography and topography. Graphic design students can create prototypes or just cool-looking models of all sorts. Anyone in the culinary industry can design molds. You can do a custom cookie cutter of just about anything you want with little wizard-based things online. And there are actually 3D printers printing in food. It's actually the same exact technology as the printers that we have today. It's a material extrusion technology, and they're extruding pastes and chocolates and doughs and things like that. So, pretty interesting wrinkle of the 3D printing. History class I like as an example because you're able to print artifacts like have the T-Rex skull, things like that. I've had teachers talk about printing something like a dinosaur bone and actually burying it in sand and having the students excavate it themselves, which is a pretty cool idea. The other example I like to give is if you take the class to the Smithsonian, for example, for a field trip, and there's an exhibit there on ancient Egypt, and they might have a mummy there behind glass, and they might have little bits of the pyramid, things like that. But none of those students can actually touch or interact with any of those things. But institutions like the Smithsonian are actually using 3D scanning to archive many of their artifacts, and they're providing them online for downloading and printing. So theoretically, you could go find a scan that they did of the mummy's hand, for example, print that out, hand it around the class, and then they have something real and visceral that they can touch and interact with and feel, and it makes that just a much more exciting and interactive learning experience for them. Same thing with the pyramid. So history can really come alive for students that may kind of get lost in the mix when it's just pure textbooks and memorizing dates and things like that. Architecture, it's a pretty easy fit, like we mentioned earlier. Designing new buildings or making modifications to others. Seeing how you could design a bridge in new ways and still have it be stable, testing things like that out. And then again, design and engineering students making prototypes. It's not on here, but things like math class as well is a great example. So I'll go to my next slide here if I can. So these are some actual examples of actual stories, people using 3D printing in education. This is on the Smithsonian site. You can actually go and download a life mask of Abraham Lincoln in a 3D printable model and print it out. And I've seen it done on printers like these. There's some filaments that actually have metal powders in them, and they feel heavier and more like metal bronze or something like that. So you could actually print out Abraham Lincoln's head and have that in the classroom and get students excited about that. Here it mentioned is the DNA type kits or anything on that. There's proteins and anything on a molecular level. You can print them out, color code them according to the different pieces and parts, and have, again, something hands-on to accompany the lesson that you're teaching. There was a teacher that was teaching entomology about insects. And what he had his students do was they learned about all the different parts of the bugs and how they would survive in different environments. So they looked around the classroom, and each student got assigned a different corner of the classroom. And they had to evaluate things like food sources and humidity and temperature and things like that. And then they designed an insect that would thrive in that particular environment. and then they 3D printed those insects. You can go online, there's free CAD design software programs like Tinkercad, where you could easily take basic shapes, thorax and a head and antenna and how many legs would it have, things like that, and then printed out the actual bugs that they designed. So a really cool, creative way to get students involved in the subject. This year is a tortoise, so kind of thinking about veterinary type classes, that had a defect of its shell. And its shell was really, really soft and sensitive and made it very vulnerable. So they did a scan of the shell, and then they 3D printed kind of a little helmet for the tortoise, so that he was able to be protected and thrive and hang out with all the other tortoises. And as he grows, they can do new scans and do a new print that is custom fit for that specific animal. There are conductive filaments that are available now, and actually this printer here, the Dreamer, has some conductive filaments. And what you can do with that, especially on this printer, which is a dual extruder printer, we'll talk more about that here in a moment, is you can print out something like a little mini working flashlight, where you're printing the body of the flashlight in plastic, and then you print a basic circuit board on the inside with conductive filament, stick a battery and an LED light bulb in there, and you have a little working flashlight. So great to teach students about electronics and all that type of thing. Rockets, building custom rockets, and also the classic egg drop experiment, where now you can actually design something in a CAD program, thinking about how you want to protect your egg, 3D print it, and then go drop it off the building, have you new wrinkle on that classic project. NASA is very into 3D printing as well. You may have seen that the first 3D printer was brought up to the space station relatively recently, and they printed out a wrench, among other things. You can actually go download the file for that wrench and print it out in the classroom. But that's really groundbreaking for space exploration and space travel, because now you might possibly need on board this ship. You just have your 3D printer and the files for what you might need, and you print them on demand. And that allows us to go much further and be much more flexible where we're exploring space travel. There's my math class example that I really like. There is a professor, I believe at Princeton University, that was studying something called knot theory. So you have these complex knots and shapes, but they were really hard to depict in a two-dimensional book because they looked different from every angle. They would interact differently with the planes of space depending on how they were turned. So she started printing out the knots on a 3D printer, and then every student would have one in their hands. And they could roll it around on the table and see how it would interact and look from different angles. And it really helped the kids to understand the concept so much better, to have that, again, tactile piece to the class. So just a few of many, many, many examples of how 3D printer can be used as an educational tool. Again, prototypes and product development, many different examples, everything from an iPhone case to custom footwear and eyewear. Again, with the scanning, we'll look at the Fuel 3D scanner over here, which is great for scanning something like a face or a foot. It's actually accurate from a metric standpoint, so from the measurements from one pupil to the other for designing a custom pair of glasses, or the shape of your foot for a custom shoe for climbing or golfing or running or whatever. Great application for scanning and printing together. Custom fishing lures, custom body armor, designing new vehicles like we talked about, all those things is a great fit for 3D printing. The healthcare field, medical and dental, is using 3D printing pretty widely already. Again, you have the imagery, so you can do a bespoke fit, whether it's a cast or a brace, or something like a prosthetic for a young child. If you think about the cost of a traditionally made prosthetic, can be in the tens of thousands of dollars. And as the child grows up and grows out of the old one, just like you do shoes and clothes, that is just not economically feasible for most families. So to be able to take something like a 3D printer, have a prosthetic hand that is a custom fit for that child, and not only that, you can do custom colors or different modifications in that personalization aspect, is really, really cool. We're going to have Bob come up and talk here in a moment. He's actually involved in a project that is making hands like these for kids, and he's brought one with us today so we can take a look at that. But really great application. Again, mentioning printing out models of hearts and bones and things like that for staying in patients and practicing procedures. The M4 printer, which is the paper printer that we have here, is used pretty widely for that, surprisingly enough. Same thing with dentistry. Dentists are having 3D printers in their office now, so when you go and get fitted for a crown or something like that, they take the x-ray, then they go on the back and make a quick model so you can do the fitting at the same time instead of having to go home and come back a week later when it comes back in. So it's really accelerating and making that process much easier and much better custom fit as well. Again, from kind of the veterinary standpoint, that dog there was in the news a while back, has a deformity of his front legs, but they did a scan, designed a custom prosthetic that let him run around just like any normal dog, and then even an earbud. So I know I always have trouble getting those earbuds to stay in my ears. But there are services today where you can go and get your ear scanned, and then they will print out with a 3D printer like this a custom fit for your earphones, so it fits there just perfect. So tons of applications from a medical dental aspect. Gaming, toys, tons of different applications as well. If you want the Doctor Who chess set or your Minecraft figure, or you want to do a model train, or you want to do a modification of Hungry Hippos, all kinds of things, even miniatures for the dollhouse industry, printing your own drones, tons of great fun applications. And then again, models and displays. It looks very similar to traditional models that are made by architects, but it actually gives them the ability to do some more custom and delicate type structures where before that wasn't really feasible from a model making standpoint. Full color is also an option. This is from a company that was providing replicas of stadiums at different universities as keepsakes for alumni. And that was a booming business for them because all these alums wanted to have their stadium or whatever on their desk. Which is a good point to mention as well. From a school standpoint, these 3D printers can be great as a fundraising tool. And that customization aspect, what have you, to do a project where the kids design something fun, or you can do something like the models or whatever, to make those and be able to do fundraising with that is something to think about in the back of your mind. Fashion and jewelry industry, from not only custom fit standpoint, but just the crazy, wild, creative new ideas that can be had. The jewelry industry is very interested in using 3D printing, even though they're still using metals, and they're not using 3D printing to print the metals. They're using it to do wax models that are then cast and cast in metal. But it allows them to do really interesting, intricate new designs. This is actually based on the nervous system, that particular artist. So again, from a creative standpoint, sky's the limit. Now, when you talk about 3D printers, it's important to note that there are many different types of technologies other than the ones we have in this room. And they range from a few $100s to almost in the millions, and everything in between. But the good news is they all basically work the same way. And what that is if you're wanting to reproduce an object that already exists in the world, so whether it's an engine or a person, you would start with that original object, and then you would scan it to come up with a digital representation of that object that you work with in a CAD program. But in many cases, you might actually be starting with step 2, where you're designing something completely new in that CAD program in 3 dimensions. You then take that object to the slicer software, is what we call it, that drives the printer. And that software will slice that object into layers from bottom to top. And the thinner the layer is, the more detailed the object would be. We'll talk a little bit about the different resolutions that these prints have, and it all has to do with the thickness of each layer. So then the printer takes whatever material it uses, whether it's plastic or paper or powder, and it deposits those layers back one at a time and rebuilds up that object. And this is why we call 3D printing additive manufacturing. And that's in contrast to subtractive manufacturing, which is the more traditional way to make something, where you start with a block of material and you drill and chip and carve away until you're left with a thing. This uses much less material, so there's much less waste, usually much less energy, and in many ways you can create much more complex, intricate type objects. There's a robot here, a purple robot that's actually printed in one piece, but it moves and has joints and all of that type of thing. So this would be really hard to make with subtractive manufacturing. And this just prints in one piece. We're trying to print a small one there. It's the same version. So assembled objects is just one example of how 3D printing has advantages over traditional manufacturing. In many cases, you'll be done at this step, where you just pop the print off and you'll be ready to go. In others, you might have to remove support material. You might have to dunk some of the professional printers. You have to dunk them in a chemical to harden them, things like that. And then you have your finished product. And that product can be sanded or painted, or you can assemble multiple pieces together into a larger object. You go from there. So all 3D printers work this basic way. Now, most of the printers, well, all of the printers in here actually use this particular technology, which is called material extrusion. And what that does is it takes a material in a filament form, just like this, usually a thermoplastic, but in some cases the food printers, like I mentioned, but anything that can be extruded into a filament is drawn through this heated head and then deposited with a nozzle layer by layer until you build up the model. The molten material cools, it hits the air, and that's basically how it works. Very simple, very easy to use. Again, mostly using thermoplastics, but you can use pastes or wax filament. The acronym we're used to describe it is called FDM, or Fused Deposition Modeling. It's a trademark term, so it's sort of like saying Kleenex for all the facial tissue out there. The non-trademark term is Fused Filament Fabrication, or FFF. I think FDM is easier to say, and most people in the industry do. So if somebody happens to say, oh, I'm looking for an FDM printer, they're in the know. That's what this type of printer is what they're talking about. It's very low cost. It's a very simple layout and process, as I mentioned. Great printer. Part of why they're seeing so many printers with this technology is there was a patent a while back that expired, and that allowed everybody to get in and innovate and create new versions of this. So as other patents on other types of 3D printing expire, which some have done recently, we'll probably see more of that type of technology come into the market. Another type of printing that is unique to a single manufacturer called MCore Technologies is called Selective Deposition Lamination. I'll get some examples here. Excuse me. And this process actually uses paper. And when I say paper, I mean your standard copy paper. You put a ream of paper into the printer, and you can pre-print it so that you get the full color effect. And then each piece of paper is that slice of material. It's brought into a chamber, glue is applied where the object is, less glue is applied where the waste material is, and then the second sheet is brought in on top of it. It's pressed up against a heated plate at the top to bond them together, and then a blade goes around and traces the cross-section of that particular area. It's very hard and durable. I'll pass this around. It actually looks and feels like a piece of wood. And these chains are actually made from paper as well. But the interesting part about it is that makes it extremely cost-effective to use. So this is an enterprise-level printer. This is a professional-level printer. But compared to other full-color 3D printing options, it's a fraction of the cost, between 5 to 20% of the cost of another full-color machine. You don't have proprietary materials. If you run out of material on a big build, you go down to the corner store and you pick up a ream of copy paper, and you keep going. And allows you to use the printer. Many universities have got 3D printers, and they can't afford to run them because the materials are so expensive, and there's toxic chemicals involved, things like that. So this company has gone a different route to make it more affordable and accessible.
What's the resolution on this stuff as compared to your?
It's 100 microns, and the reason why is a single piece of paper is 100 microns thick. So there's one layer resolution on that particular printer. So, and you can chromatic, where it's basically just the color of the paper that you put in the machine, or again, you can do the full color, where it's pre-printing the pages with a special ink that actually soaks through the paper, prints on both sides, because what you're looking at with that model, in most cases, is a cross-section of the piece of paper. Because it is using paper, many times on other printers, they'll spend the time to hollow out the object because it's so expensive to use that material, where here you can print a good solid object without having to go through that extra step. You can actually use it for casting as well, for metals. Just a very unique version of the technology. So I like to go through the steps on how you make your first 3D print just to answer some questions that usually come up. And the first question is usually, how am I going to use a 3D printer? I know nothing about CAD. I don't know how to design anything. What am I going to print? And the good news is there is a wealth of great 3D designs out there. Many of these models came from a site called Thingiverse. There's also MakerBot has their digital store as well, which is sort of like an iTunes for 3D print files. They have some really great designs like the T-Rex skull. They have a saber-toothed tiger skull, and they have some Sesame Street licensed stuff. There's also, as mentioned, the Smithsonian site and NASA's site both have 3D models that you can download. So you just go find something to print. That makes it pretty easy. You can also create your own without having any knowledge about CAD. Autodesk 123D has a suite of apps that are really great and easy to use. You just use different sliders, different parameters to make a custom base or custom creature for your students. Again, sort of the bug model. Tinkercad is a great free online CAD learning program. Great tool for that. And then if you want to duplicate something or replicate something that already exists in the world, a 3D scanner is a great way to get custom content that you can then make 3D printable. So the next thing is to choose your materials. And for these FDM printers, there are two main types of plastics. And the first is called ABS. And that's basically the same exact plastic that Legos are made out of. So if you think of a Lego as very hard and durable and strong, that's what ABS does. It prints at higher temperatures, melts at higher temperatures. It can emit a little bit of a plasticky smell, which sometimes isn't great in the classroom. But a printer like the Dreamer is great because it is fully enclosed, so it keeps any fumes in there. And also, because it prints at a higher temperature, it has a tendency to warp a little bit. If the print cools too fast, it shrinks up and you get some warping problems. But something like the Dreamer that has a heated bed and it keeps all that heat in there prints especially well with ABS plastic. PLA is the other type of plastic. It's a bioplastic, so it's made out of corn or soy. A lot of times the little clamshell box your strawberries come in the grocery store is made out of PLA. It's recyclable, it's biodegradable, it smells kind of like pancakes when you print with it, so there's no fumes. It's a great user-friendly plastic. I think it's great for schools. MakerBot uses PLA primarily. You can use PLA in the Dreamer as well as other printers. Really great user-friendly plastic. It can be a little brittle sometimes on the spool, so especially if it's cold, it might snap a little easier than other plastics. And it does use lower temperatures, which is kind of nice. You don't have to have a heated build plate. So this is not heated, where this build plate does heat up to 100 degrees or so. Two great plastics, both have great advantages and are easy to use on printers like these. There are also a lot of what we call exotics. Yes?
PLA, how biodegradable is it?
As far as like how long does it take?
Water.
Yeah, I'm not sure. That's a good question. That's something that we could look at.
If you put it in the back of your window on a hot summer day, it will melt.
Yeah.
So that's one thing you can say about it. As far as being biodegradable, it's going to be a while.
Yeah. I think the non-eco-friendly part about the PLA are the dyes that are in them. So in general, at this point in time, you wouldn't want to use PLA for like utensils, something like that. There's going to be more and more food-grade plastics coming on the market, but it's a good question. We can look it up. It is recyclable, though, a little more readily recyclable, and there actually are some filament producers that are producing recycled filament that's using recycled content.
Is it edible enough? If my 3-year-old starts chewing on it, am I going to have to start to
I don't think so. I have a 2-year-old daughter, and she's calls them DVD printers. But she's, one gets in the mouth every once in a while, and don't worry about it too much. But you wouldn't want to make it for your coffee cup that you drink out of every morning. And to your point, they do get, if you left it in a hot car, it would get a little melty and soft. Yeah. So the exotics are pretty exciting. There's more and more of those coming out. I mentioned the conductive filament. There is wood-like filament, ones that feel like stone, ones that feel like bronze when they're done. There's nylons and polycarbonates for really hard and durable type materials. There are flexible filaments, so instead of hard plastic toys, have something more rubbery and squishy. And then there are two types of materials that are mainly used for support. So as you think about printing that object up from bottom to top, and you look at the rabbit, when you get to the ears here, if you think about it, you're printing out straight into thin air. And at a certain point, that's going to want to droop down and sag if you don't have something to hold it up while it's printing. So we implement what's called support, which is basically scaffolding for your 3D print while it's being made. And you can do what's called breakaway support, which means the scaffolding is made out of the same plastic that your model is, and then you literally just snap it off when you're done. That can be a little bit of a tedious process. It can leave some rough surfaces on your model depending. So if you have a dual extruder printer like the Dreamer, you can actually load a separate type of filament in the other extruder to use for the support. There's PVA, which is soluble in warm water, and then there's HIPS, which is soluble in a special type of solvent called limonene that's made from citrus. So what you do is your rabbit is printed in your PLA, and your support is printed in your PVA. At the end, you dunk them in a bucket of hot water, the support dissolves away, and then you have your rabbit pie. So all kinds of options when it comes to filament for all different kinds of applications. Now, calibrating your printer is an important part to success. One is to level the print bed, so the surface that you're printing on should be as level as possible. The MakerBots are pretty much automated. This one will go around and prompt you, and you turn the little knob and a light comes on when it's at the right height and makes it level. The Dreamer is very easy as well. You use a piece of paper to slide back and forth and go around and you adjust some thumb screws on the bottom. Adjusting the nozzle height is also a very important step. If the nozzle is too high, your plastic isn't going to stick, it's just going to kind of go out into the air. If it's too low, you're going to prevent the plastic from extruding. So if you think of putting your thumb over the end of the hose, you'll have that problem. Or if it's too low, you might actually scratch the print bed. So you want it at the exact right height to give a nice, what we call flattened bead of plastic that goes across. And most of the printers do these two steps at the same time. So when you go around to the different points of the bed, and you move your piece of paper or you turn the light on, it's setting what we call the nozzle gap, and it's leveling the print bed at the same time. Last but not least, you want to fine-tune your temperature. So it's not only the temperature at which your plastic is going to extrude or melt correctly, but if you have a heated bed, you also want to adjust that temperature so that your print will stick and you avoid warping problems, things like that. So something like the Mini actually is pretty much fully automated when it comes to calibration. There's 3 little points that the nozzle touches on to do the leveling and the gap. And for temperature, most of these come with presets that work really, really well. So you don't necessarily have to know about that, but you do have the control to adjust those as needed. So last but not least, you want to choose your settings and print. Now something like the Mini is going to have a smaller build volume. So the size of the object that you can print in there is going to be somewhat limited. Where printers like these are sort of a medium build volume, and something like this, you would need something like a MakerBot Z18 to print something really, really large. So one consideration is how big of a model do I want to be able to make? Keeping in mind that you can still assemble things together to make big, big parts, but one consideration when you're considering which 3D printer is the best fit. The next is the resolution or layer thickness that your printer is capable of. Now, pretty much all of these printers are capable of about 100 micron thickness, and that, again, is the thickness of a piece of paper. Many of them, the flash forwards will actually now go to 50 microns, so half of that. Some printers are actually saying 10 microns. I'm not sure how much you'd be able to tell between 50 and 10 microns, but it's an impressive specification. Now, the other thing to realize when we're talking about layer resolution, so it has to do with how smooth the part is and how it feels. This particular model was done at 100 microns, so the helm is actually pretty smooth. Some of these other prints, like the rabbit, was printed at 200 microns. You can kind of feel the little ridges on the side. And so, in the case of the rabbit, it doesn't really matter, and you go a lot faster when you have those thicker layers. Something like the Athena sculpture, you want to maintain those fine features and details. You might want to take that extra time for that longer print to get that smoother surface. Infill is the same thing. How solid or hollow is your object? You can get a very strong and durable print at between 10 and 20%. You don't have to have it totally solid. And you probably don't want to because it takes forever and you use more materials. And just one more consideration when you're building your print. So again, if you want to do dissolvable support or you want to do a two-color model, you would need something like a dual extruder printer. And then you're off to the races making your first 3D print. So that's it for the presentation. Are there any more questions for now? Great. Well, we're here. We have all these printers going. We have some 3D scanners going. I could do some demos of the Field 3D as well, but thank you for your time.